Hi, I'm Adam Van Cleveren, and this is assignment 2 for Big Data Technologies, Comp 8.2.10. So the first task of this assignment is to clean up the Twitter dataset, including 10K tweets. So for starters, what I do is I read in the file and remove the numbering from the text file, and then write it to another file. From there, I remove the object ID for all tweets, and then write it to a new file. From then, we remove the regex containing these symbols, just because that's also not JSON serializable, so they get removed, and I put it to another file. From there, we put the comma in between the end of each tweet, because they need to be separated by a comma, so they can be put into a list, and write that to a new file. From there, we basically just remove the white space between the parentheses and the comma, just because that throws out an error for JSON files as well. The last variable removed is number long, just because that also does not fit the schema. And once it's all done, we write the object into a list, and that is essentially the file. You can view the file just here. This is a notepad of the final output. It shows that everything's in a list, all in order, contains all the needed items, and you can see it's a bit here, so it can be read in. From here, basically, we just import all the attributes and relationships. I'm just going to show this through the spider, as I've already done on the Neo4j, and it removes a couple of the previous transactions, so it's just easy to do through here. So basically with this, cool using the a.period_iterates function from that clean up tweets. And for this statement, I'm basically just reading in the tweets themselves and all the values that need to be used for this assignment. So we pick posted timestamp, text, language, retweet counts, favorites, verb, and ID. And then we merge these onto a new node called T, otherwise known as tweet, with the ID equaling ID. And then creating the set of properties underneath the main property ID, being named posted timestamp, text, language, retweet count, favorites count, and verb. So those will make up the key value pairs. Next thing, we insert all the links. So we grab the link from the value, which is the file again. And from there, we match the tweet with the ID that we done previously in the last step, and then merge this new link to connect the ID and the link with the contains relationship. Next step is to bring in the sources. So we essentially, all we need for that is the display name and the ID again. So we then match the tweet again with the ID, and then merge it with the new source for each tweet. It's using the using relationship as shown here. Next thing is we'd use the a.period iterate statement again, and we're basically just importing the users. So this is, we get the preferred username for the first step of this. These are the people that are making the tweet, so that's what they're called by on their either Facebook, Twitter, whatever their login is. And we then match it with the ID again for the tweet, merge this preferred username under the username key, and then that will be stored in the user object or node. We then merge U to T with the posts relationship. Third last thing we do is we basically need to import the hashtags. So again, we do the echo file statement, and with this we match the tweet again with the value ID. We then take that value of the hashtags as hashtags, and because some tweets basically contain a list of hashtags, we have to unwind the hashtags so we can get each individual hashtag by themselves. And from that, we basically take each tag within the hashtag list, and then merge it to the document using the tag, each tag, and then the text from that, which is how it's stored in the file. From that, we then merge a relationship between the tweet and the hashtag and call that relationship tags. Next, we do a similar thing with the user mentions. We match the tweet with the ID value again, pull the user mentions and the tweet node. And then because there can be multiple mentions again, we have to unwind that list into individual items and then call each item from mention and user mention and grab essentially the screen name from each of those mentions and then merge that mention relationship from T to U. The last relationship we have to do is essentially the retweets. So to do this, we just match the tweet again with the value ID. Basically with this clause, we want to find the retweet, so we need to find the verbs, or anything that the tweet contains the verb share in the key value pair. So all those objects that do will then be will then create a retweet node from that connection. And we do this by creating a new node called retweet, and then match the retweet ID with our new key. And then we merge the relationship T retweets retweet. So that's the last of part 2. The next part we will do in Neo4j. So these are the queries I'll be using, and I'll be inserting them one by one into Neo4j to show the outputs. So for question 1, it is to just find the top 5 most used sources, which whether app it is or for Apple site from every post or share tweet. We have to return the source name and the number of tweets sent via that source. So this can be done with the match statement T using S, which is the tweet using source. We then want to return the display name as a source, which is essentially the source that is being used from the key value pair. And then we also want to count that to find how many times that source is being used. And then we order by the count descending, so we can see from top to bottom. As we can see, for the top 5, Twitter for iPhone is the most used, then the Twitter web client, then Twitter for Android, then TweetDeck, and lastly Twitter for iPad. So for question 2, we essentially want to find the top 5 hashtags used across all tweets within the days from the 26th to the 31st of March, inclusive. So for each day, we want to find the date and a list of the top 5 hashtags. This can be done through running this query here, where we match the tweet with the tag relationship to hashtag. And then with the tweet, we want to take out the posted timestamp as date and the hashtag from the hashtag node as hashtag. We then want to filter with the where statement the date, and it has to be greater than or equal to this 26th of March and less than or equal to the 31st of March. And we also want to remove hashtags that are null, just because they just get in the way of the data set, and we don't need them. From there, we take the date function on the date, so we can get it in day, month, year format, or sorry, year, month, day format. And then we also want to pull the hashtags out of that for each hashtag and an account of the hashtag, so we can basically get the frequency of each hashtag occurrence for the day. From there, we want to order the day by the day descending, so that's why it's in 30th first, 29th, 28th, 27th, 26th. And then we get the counts by descending, so we get best value, which is the top use of the 30th, and so on. A few of the days, as you can see, only have 4 listed, just because they don't have any more than that many hashtags used on a certain day, which can be shown in our last statement with the return statement, where we get the day where we collect the hashtags to a list. That's what the collect function does, and we want from index 0 to 5. That will give us the top 5 hashtags. And as you can see here, these are the most 5 used hashtags for the period. So for question 3, we want to find all users that use any of the same hashtags as the user mrazam. This query must exclude retweets, which it does. They're not connected in this one. And it should automatically contain common tags. So yes, this query, we match for the user with the username mrazam, so we're using it as a comparison. And so we want to find the hashtags that are common with other people. So to do this, we use the post relationship to get to the tweet, and then traverse to the hashtag node through the relationship of tags. So we need to use the with distinct hashtag statement, just because we want to find each individual's count of the hashtag. So it's not separated into each one. From there, we want to match a suggested user with the post, tweet, and tags the hashtag with whatever hashtags mrazam uses, which is stored in this hashtag statement. From there, we want to make it so suggested does not equal the me user, which is mrazam, just because otherwise it was trying to get instant match will show that he's the most user that's in common with himself. So that excludes that. And then we use the with statement to get the count of the hashtags for suggested as common, and return the suggested username, which is the user that's most in common, and then how many tags in common he has with mrazam, and ordered by common descending, which shows the hashtags in common. We can see from this that Bardos has the most in common with 2, then the rest seem to have 1, so the ordering isn't too important for those. But if it was, it would follow suit with this query. So for question 4, basically what we want to do is create a synthetic relationship between users that mention each other and assume that they follow each other. So to do this, what we do is we want to match user 1, which is calling user 1 for ease. And for the relationship, we have to access the tweet node to then reach the other user for the mentions. So we have to go traverse from user 1, post, tweet, and then mentions friend, which is another user. So we take u1 and friend and merge u1 follows friend. So we're creating a new relationship with follows. We want to set the weight for that first person as 1 for that relationship. So every essential follow is worth the same as every other follow. And then because we want to do the same relationship backwards, we need to do merge friend follows u1. So you can traverse it either way. We also set that weight to 1 for the friend, and then return each one. It's probably a bit easier to see in the table format. We can see the weight being stored here and the username, and the weight and the username again. So the last question of this assignment was to essentially use the relationship derived from this question to find which user has the highest centrality score. So meaning it's the most popular node in the data set that we are given. So this statement's not going to run, but just because I've already done it before. But if you use this code format where we create a new graph project. Sorry, 1 second, it's just loading. Should be 1 second. There, but we'll put back in. So from this one, we essentially want to create a new graph called follows weighted, which is our weighted points as shown here, and we're taking this relationship with the user being the node that we're trying to look at, and the relationship being follows. For this, because we're weighting the relationship, we take the weight which we created before and implement that as the relationship properties. So once this is created, we can then do a centrality score, which we do by just inserting this query. And once we run that, it should give us which users have the highest centrality. So as we can see, from this, basically what we're doing is GDS PageRank. PageRank is the best graph data science library to conduct the centrality. Basically what it does is it grabs a node ID and gives a score from PageRank. We then take the node as node ID and then call it n and the score as PageRank. And then what we're doing is return the username, which as user, and the PageRank is PageRank. And we want to order by whichever score has the highest PageRank, therefore has the highest centrality. So as we can see here, the list is quite long, but so I'm just going to explain for the first ones. So YouTube is the top, the highest centrality. It has a PageRank of 35.36, so on. And then we have Alhanda 25.52, El Jazar 14.63, Civil Society Oz 14.61, and Twitter Blaster 14.33. I should just add the 5 as a statement of the question, as we only want the top 5. And this should correct just to meet the question requirements. So there's the top 5 centrality, and yes, that should be all for the assignment. Thank you for listening, and I hope you enjoyed it. Cheers.